number 19 from the review sheet. In this problem, a slingshot fires a pebble from the top of a building at a speed of 14 meters per second. The building is 31 meters tall. We're going to ignore air resistance and we're going to find the speed of the pebble as it strikes the ground when the pebble's fired horizontally, straight up, and straight down. So I've got my drawing. I've got my initial speed of 14 meters per second in all three directions. I believe part A asks for horizontal first, so that's what we'll do first, and it'll follow this curved path right there. My equation, I'm going to use conservation of energy. So I've got the initial potential plus the initial kinetic equals the potential and the kinetic put together at some point later. First thing we have to do is cancel out any energies that don't belong. So initially, the pebble is moving at 14 meters per second, and it is way up off the ground. It's the highest point that we care about it. So it's going to have both potential and it's going to have kinetic. Later, it's going to be down at the ground, so it will not have potential energy because it will have lost all of that gravitational energy by traveling all 31 meters down. But it will have kinetic because we are always interested in it as it's about to hit the ground, not after it's hit and stopped. So from here, we just have to expand our potential energy and kinetic energy equations to the variables that make them up. So potential energy is mgh, kinetic energy 1/2 m v naught squared, and the kinetic energy later is 1/2 m vf squared. You'll notice each term has an m in it, so we can divide m out, and that will cancel in each term. That leaves me with gh plus 1/2 v naught squared equals 1/2 vf squared. This problem is asking for us to find the final velocity, so that's what we're going to do. So we're going to move the 1/2 to the other side of our equation. So I get 2 gh plus 1/2 v naught squared. And that would give me vf squared, but I don't want vf squared, so I'm going to take the square root of that left side, and that gives me just vf. I can plug my numbers in, and I will get 2 times 9.8 meters per second squared times 31 meters plus 1/2, 14.5 meters per second squared. And all of that will give me VF. When I plug all of that into my calculator, I should get an answer of 28.35 meters per second for the speed of the pebble as it's about to hit the ground. Now that was the answer for part A, which is how fast is it going when you fire it horizontally. But that's the really nice thing about energy is it's what we call path independent. So it does not matter if it was fired horizontally, fired straight up, fired straight down, or at some kind of a strange angle. My energy equation would be exactly the same. I'd still have the same potential energy to start, I'd have the same kinetic energy to start, and I would end up with just kinetic energy at the end. And all of the algebra and all of the math would be exactly the same. So as a result, the answer to this problem is the exact same for every part that we've done. And that's how we do it.